In this video, we will look at frame synchronization. Specifically, out of the three methods that are listed here, we will be talking about the second one, called byte-stuffing frame synchronization. There are different names given to this technique. One of the names is also character stuffing frame synchronization or character-oriented frame synchronization. Sometimes two of the names are used simultaneously, like for example, character-oriented, character-stuffing frame synchronization. We will be concentrating on the figure on this slide. The principle of operation of this technique is to add predefined characters that will mark the beginning and the end of a frame. The top figure here shows an SDU. This is an SDU of layer 2. These characters, PC5TX, were received from layer 3, and layer 2 is going to prepare them for transmission before passing them on down to layer 1, to the physical layer. The bottom figure here shows the way the characters will be passed to layer 1. You can see on the left and on the right in blue the two characters that are used to mark the beginning of the frame and the two characters that are used to mark the end of the frame. The beginning is marked by DLE-STX. DLE is an escape character. The name DLE comes from data link escape, and the STX is the start of the text, and it stands for start of text. At the end of the frame, you can see again the data link escape DLE followed by, in this case, an end of text character. These are standard ASCII characters. Let us now illustrate the way the technique is used for the transmission of two frames. In this slide, you see two systems, one on the left consisting of layer 2 and layer 1, and one on the right which has also layer 2 and layer 1. Layer 2 begins by receiving from layer 3 above it two layer 3 PDUs, which, as you know, are called layer 2 SDUs once they are received by layer 2. Layer 2 uses the technique that was described in the previous slide to add the beginning and ending characters to each one of the layer 2 SDUs. And then it passes all of these characters on down to layer 1, as we can see in this slide and we just saw in the animation. Layer 1 will take all of these characters and transmit them through the transmission medium to the system on the right. All of the characters will be transmitted one after another without making a distinction or a pause between successive frames. Layer 1 receives that sequence of characters and it sends them on out to layer 2. And it is layer 2's responsibility to be able to separate them. Layer 2 will actually use the start of frame and the end of frame characters to be able to accomplish this task. Once all of these blue markers are removed, layer 2 will be able to pass on to layer 3 exactly what layer 3 had passed to layer 2 on the transmitting end, as illustrated in the animation in this image. There is a potential problem with this technique, as we will discuss in this slide. Here at the top, you see the SDU before adding the start of text and end of text characters, and also the escape characters. On the bottom, you see the resulting frame in which the DLE-STX has been added at the beginning and the DLE-ETX has been added at the end. Notice, however, that because DLE-ETX appears in the text itself, in the SDU itself, layer 2 at the receiving end would be confused and would think that the frame actually is composed of only the three characters P, C, and 5. The solution to this problem is to add what is called a transparency character, which will be illustrated in the next slide. Here, we will concentrate on the figure on the right. Notice that the top contains 6 characters PC5 DLEETX L. it is that DLE ETX that poses a problem. If we use the transparency technique, the layer 2 will see that there is a DLE in the SDU, and it will insert an extra DLE immediately after it. That is marked here in blue. It will finally add the markers for the beginning and the end of the frame, DLE STX and DLE ETX, as shown in this figure. The receiving layer 2 will need to handle the sequence of characters that are shown here at the top, containing both the start and end characters for the frame and the transparency DLE or DLEs, depending on the case. The first thing that it's going to do is to go through the frame and try to find all instances of 2 DLEs in a row. It will then take one of the DLEs of these pairs, remove it, and interpret the other one as being part of the data and not a control character. Once it's done this process, for this particular frame that we are dealing with in this example, it will end up with a frame that looks like the one in the figure in the middle, in which only the doubled or the repeated DLEs have actually been eliminated. Once these DLEs have been eliminated, the next thing layer 2 will do is to go through and find the starts and the ends of the frames by detecting the DLE STX and the DLE ETX. Those will then be removed and the frames will be separated. The resulting SDU is found in the bottom figure. This slide contains 2 exercises. You can pause the video, read them carefully, and solve them. If you have any questions, do not hesitate to write to me and we can solve them either the next time we have a class or I will give you some feedback also by email.